Hello folks, we're going to talk about math. Math has a long history. It starts with arithmetic, algebra, and we also develop trigonometry. That is the science that studies the sides and also the angles of a triangle and the unit circle. In this project, we're going to talk about those trigonometric functions. We're going to demonstrate some of them with graphs, the inverse functions, and we are going to see also some application problems. What kind of problems? We're seated at the cinema. That is a problem that you can solve with these trigonometric ratios. Also, we're going to see how to apply your values into a trigonometrical ratio or the trigonometry to know the answer for certain questions or to graph, and that is really helpful. Follow me, I will explain you something. First, we have laws of sines and law of cosines. Law of sines is ratios between angles and the corresponding sides in a triangle, and you can use it in two cases. When you have two angles and one side that is corresponding to one of those angles, or when you have two sides that is one corresponding to one angle that you have given. Then we have laws of cosines. What is that? Okay, it's almost the same, but you have only two cases there. When you have two sides and one angle that is not corresponding to one of those sides, or when you have three sides. Now follow me, I will explain you something else. Oh, you actually follow me? Okay, I will explain you something. But first, let me show it. Can I see it? Yes, of course, if you can explain me what is harmonic motion.
An example of simpler harmonic motion can be found in high jump. It is defined as any motion where a restoring force is applied that is proportional to the displacement and in the opposite direction of that displacement. Simpler harmonic motion is similar to the periodic behavior, ergo, a motion that repeats over and over. Using trigonometric functions can be ideal to model the periodic behavior as the graphs of sine and cosine.
Now, I don't really want to explain you.
Really?
Yeah.
Okay, see you. Well, I was telling you something, right? Here we have the arc ratios that are the inverse functions from the functions. Actually, it's easy to explain. They're just the inverse ones of the originals. Here we have arc cosecant. The function is like this. The domain goes from -1 to 1, not included. And the range goes from -1 half of pi, included, to 0, not included. Or 0 to 1 pi over 2, included. This is the graph, as you can see. Okay, we're going to see arc cosine. The graph, well, the function is like this. Cos to 1, this time included. And the range is from 0 to pi. This is the graph, okay? Here we have the arc tangent. The function is like this. We know that the domain is from negative infinity to infinity. Obviously not included. The range is from -1 half of pi to 0. Not included, or 0 not included to 1 half of pi included. And this is the graph. And we also have the arc secant. It's sec to the -1. The range here, the domain here is from -1 to 1, not included. The range is 0 to 1 over 2 pi, not included. And it looks like this, okay? And we have a last one, the arc sine. Arc sine function is written like this, okay? See, the main here is from -1 to 1 included. And the range is from -1 over 2 included, pi to 1 over 2 pi included. This is the graph, okay? Well, we're going to eat something because I'm really, really hungry. So, follow me. Really? Are you still following me? I'm so hungry.
Hi, can I sit?
Yes, of course. Only you can explain me something about trigonometry.
Well, I can explain the angular frequency.
Okay, go ahead.
Okay. Wow.
Oh, what is that?
Imagine this little piece of pizza represents an angle.
Okay.
So the angles represent here in time. So the angular frequency explains this is the angle, this is the time. Why represents time. So that's about it.
Really?
Yeah.
Just that?
Yeah.
Well, take your piece.
Thank you.
Well, you know the rule. You have to follow me. Really? Okay, you found me. Follow me. I will teach you some application problems for the trigonometry. Oh, hi.
Hi.
What are you doing?
Studying.
Can I sit?
Yeah, for sure.
So what are you studying?
I'm studying the amplitude of the sinusoidal curves.
What is that?
Well, it's the distance between the center line or equilibrium line to the tallest peak, or from the lowest peak to the highest peak divided by 2. And it's represented by the letter A.
Okay.
As well, I'm studying the period, which is a high peak and a lower peak together. That will be one period.
Oh, okay.
And it's represented by a letter T. And the frequency is the amount of times that a unit repeats itself per unit of time. Sometimes represented by hertz. Have you heard of that?
Yes, a little bit.
Yeah, more like physics and stuff like that.
Yes.
So yeah, that's about it.
Well, thank you.
Yeah, no problem.
She's crazy. Hi. What are you doing here?
Hey, what's up? I want to know where should I sit to see the most.
Okay, let's say you're this one, okay? And this is the angle you want to know. Which one is the best for you to sit? Okay, let's imagine that there's 7 feet from the board to the first row. This is a movie theater, okay? It's 22 feet, okay? Now, how to solve it is the question. We want to show that this angle is represented like this. Okay? We know that this is not a straight line, and we don't know the value of this angle. But we know that we can create a straight line here. Okay? Now, we're sure that these are 4 feet. So, from here to here, there are 10 feet. So, it's going to be 4. And I know it's not in scale, but it is supposed that from here to here, it is 6 fits. The tangent is actually opposite over adjacent. And now we can know that, for example, we can create this angle here, and we can create also this. Okay, let's call this angle green, and let's call this angle blue. We know that for that red angle, now we're going to make that in an equation. Tangent of 28 x minus 6 over x. Okay? And we want to know, by using this subtraction formula for tangent, that is this one, we want to know what it's going to give us. Okay? So now I'm going to make it over here, so I can have some space to use. So now, this is the final value that we're going to get. And if we make this function, we can do it. And this is what we're going to get. As x increases, we're going to get different values. But we want the value with the bigger angle, which is 13. These are going to be the fits. It has to be away from the wall, and this is the graph. As you can see, it goes here, and here, and this is the biggest value we can have here. Okay, so now let's return. We said 13.
But what will happen if we have an inclination and the floor is not flat?
I don't really know. Maybe you can teach me.
The floor is not flat, we have an inclination of 20 to 25 degrees. To solve this problem, we will apply the law of cosines and the Pythagorean theorem. The line of the segment BP, so 7 feet plus x by cosine of the angle. Okay, now we define the segment between P and T. This is the addition of 10 feet plus the height of the screen, that is 22, so it is 30 minus this side, that is y by sine of the angle, plus 4 feet. So this is the subtraction, and it results 28 minus x by sine of the angle. And the segment P to B is defined by the same segment, x by sine of the angle plus 4 feet minus 10 feet, that is x is equal, well, x by sine of the angle minus 6. So now we have three important segments, B to P, P to T, and P to B. And now that we have all those segments, we can define, according to the law of cosines, this is A squared and B squared. And now that we know, well, how did I get A to the square and B to the square, it is easy. Just substitute x for for the value of 7, then plus 3, 10, 13, 16, 19, and then if we graph those values, we will notice that the maximum value, we will notice that is in the third row when x is equal to 9, the decrease will be 49.69 degrees, and the graph will look like substitute the values to x. The graph will look like this, and the maximum value for the angle is 49.69 degrees. That will be like this when x is equal to 9. So the best place to see the movie theater or cinema is in the third row according to those measures.
The table gives the average monthly temperature in Montgomery County, Maryland. We can see a scatter plot of the data with the given points, knowing that January is month 1. To find the cosine curve that models the data, with the equation y equal to cosine of k multiply x minus b plus c. Here we can see the graph with the basic equation of cosine. To find c, we add the maximum value plus minimum value and we divide it over 2. That gives 62.9 and we change it in the equation. To get the amplitude, that is a, we do the same, but now subtracting the values. The result is 22.9 and we substitute in the equation. To get the period, we are going to divide 2 pi between k. K is equal to subtract the amount of the maximum value minus the amount of the minimum value multiplied by 2. That is equal to 12. The result will divide to 2 pi, that is equal to 0.52, and is changed in the equation. To find the last value, that is the horizontal shift, is equal to the amount in which the maximum value is found and is changed in the equation. The equation remains as shown in the graph, and the equation is y equal to 22.9 cosine of 0.52 multiplied x minus 7, all that plus 62.9. Another form of application is to measure the characteristics of ocean waves. With these calculations, we can predict the frequency of the waves. We can also use it to know their size or amplitudes. However, with this you cannot predict how the waves behave accurately. Asking how the waves are measured, these methods can be used to measure the sound waves and their characteristics. Characteristics such as amplitude and frequency define the pitch and volume of the sounds.
Math is everywhere we look. It doesn't matter where we look at it, it is present. We can conclude that trigonometry does help many professions like engineering, physics, aeronautics, and more. We learned that the basics of sinusoidal curves and its components, as well as a lot of science of a lot of cosines, how to solve problems and what we consider important, how to work as a team and make everyone understand everything.
I find this topic difficult because it's hard to graph everything into something that you don't know values of. It's also interesting to know what trigonometry is for and how it's used in our daily life. I think that I will be using this topic when I graduate from civil engineering.
It's pretty difficult to understand this topic if you don't know the basis of it. Trigonometry works in many ways that are present on a daily basis and we don't see it. In the middle of school, I was taught that this topic and my teacher told me that trigonometry takes care of many plane trips or the construction of highways. So I was impressed because it takes care of everyone nowadays. It worries about our safety.
Studying and applying knowledge of trigonometric functions as well as law of sines and cosines can be difficult when we don't have direct measures. But we have to find the relation between trigonometric ratios and finally finish arming the equations with these mathematical relationships. This topic involved functions of sine and cosine. Both have similarity with simpler harmonic motions concept. Furthermore, when sinusoidal adjustment is used, it is easier to predict events and results graphing the sinusoidal curve according to the data.
Math is used for everything. Well, almost everything. I'm really impressed of how can you solve sort of that sort of problems that you think, oh, okay, this could be solved with math, and yes, it could. For example, the cinema problems, that's were crazy. I never thought that you could calculate the angle and actually see where you should sit. It's really crazy. Also, I learned that you could graph your functions or your data, and it will be really helpful for you to see graphically. I think trigonometry is really useful because of the uses you can make. It has a lot of uses. They're infinite, really infinite. Um, you can calculate almost everything, and that's kind of crazy. I really want to learn more about trigonometry, and I think this project help us to learn the basics of trigonometry.